The internet is full of videos of cats and dogs that talk. Cute? Absolutely. Real? Not even close. Animals don't speak the way we do, but they definitely communicate. Your dog marks a tree on a walk, and every other dog instantly knows who passed by. Monkeys and rodents warn their group about predators. Animals use posture, scent, and sound to send messages. But can we call that a language? In some cases, yes, and surprisingly, one of the most advanced animal communication systems belongs to bees. But let's not jump ahead. First, what even counts as a language? It sounds simple, but it's not. American linguist Charles Hockett spent years comparing human languages with animal communication systems. He identified 16 features that all human languages share, and only a few animals come even close. Here are 4 of the most important ones: discreteness, interchangeability, displacement, and openness. Discreteness means you can build millions of messages from a limited set of symbols. With just 26 English letters, you can write Shakespeare, or a chaotic TikTok comment. But a dog wagging its tail? That's one whole signal. You can't break it into smaller, meaningful parts. No matter how fast or slow the wag is, the message stays the same: I'm friendly. Ground squirrels, though, they're impressive. Take the Richardson's ground squirrel. It uses short chirps for aerial predators and trills, basically rapid chirps, for ground predators. Different sounds equals different danger levels. Combine them, and you get messages like, "Hey, something's flying above us," or "Run, there's a weasel." Interchangeability means the sender and receiver can swap roles. Any human can say, "I'm cold," and anyone else can say it back. But take the stickleback fish. A female signals she's ready to mate by showing her swollen belly. The male responds by changing color. They communicate, but they can't swap signals. The male can't grow eggs, and the female can't turn bright red. Gibbons, on the other hand, pass the test. Any gibbon can announce, "I found food," and any other gibbon understands. Displacement is the ability to talk about the past, the future, or things not currently visible. A dog wagging its tail or a fish showing its belly, that's strictly here and now. Openness means you can create brand new messages. Even if you've never been bitten by a snake, you can still understand someone saying, "A snake bit me." Gibbons can't do that. Their vocabulary is basically danger or food. That's it. And now, bees. Their communication system doesn't meet all 16 of Hockett's criteria. But it checks off the 4 we just covered, which is already wild. Bees communicate through dances. Zoologist Carl von Frisch was the first to decode their system. He noticed that if one bee found syrup, soon the whole hive showed up. Watching bees in a glass hive, he discovered how they share information. A scout bee returns from foraging, flaps her wings, and spreads the scent of whatever she touched. The others memorize the smell. If she performs a round dance, the food is close, within about 100 meters. If it's farther away, she performs a waggle dance, shaking her abdomen while moving in a figure 8 pattern. The angle of the waggle tells the direction relative to the sun. A scout bee returns from foraging, flaps her wings, and spreads the scent of whatever she touched. The others memorize the smell. If she performs a round dance, the food is close, within about 100 meters. If it's farther away, she performs a waggle dance, shaking her abdomen while moving in a figure 8 pattern. The angle of the waggle tells the direction relative to the sun. So even if animals don't talk the way we do, their communication systems are far more complex than they seem. Who knows? Maybe they even think to themselves, "It's nice to have someone to talk to, just in case." And that's baby science for you.